Welcome to the second video in the sessions related to simulation-based health professional education. And in this video, we'll be talking about the science behind simulation in health professional education. The science behind simulation in health professional education could be well explained through these called learn cycles, or what we call it experiential learning cycle. In this core cycle, we have concrete experience, reflective observation, abstract conceptualization, and then active experiment. And they are interconnected with each other. So in concrete experience, this related to the simulation scenario, students try to apply what they learn, we educate them, and then they apply what they have learned. Because this Kolb cycle shows that experience alone is not enough. So students, they need to reflect. And the reflection typically should take place during the debriefing phase of simulation. This is very important thing that we have to consider, and debriefing is important element in simulation. Then to turn the experience into to updated mental models and practice, then this need abstract conceptualization, so that they can change, students they can change how they act in the next time. So if we run a simulation scenario and skip the debriefing phase here, just training on mannequins or whatever, we'll do a serious thing educationally. We will waste it most of the educational value, because the scenario is only considered as the raw data. We don't learn from the experience, we learn by reflection on experience. So the debrief is where learning happens. Without debriefing, simulation is stopped at the top box. So this is a clear message that we want you to understand from this video. And learning will be left to a chance. So whenever you think about simulation, think about this Kolb cycle. You have the scenario, you have a debrief, you have developmental models, and then you prepare the students for the next practice. So please give a considerable weightage to debriefing. Now the next slide will be informing us about the staging of the simulation. Pre-briefing, in which we set the theme and set the stage and do the preparation, then we'll do the simulations, and then we do the debriefing, where students learn, where they reflect, where they practice, start to be prepared to practice for the next time. Let us now see the debrief practice, or the deliberate practice, because this is considered as a classical model of simulation. We cannot just abstract simulation in 3 stages: pre-briefing, simulation, and debriefing. No. They should be a deliberate practice. Actually, Anders Ericsson spent decades studying how people became experts, from concert pianist to chess grandmaster to elite surgeon. And his finding, it is not talent, it is not just time, it is deliberate practice. And deliberate practice is known as structured, repetitive, with feedback at the edge of your ability. And simulation is the only environment in medicine that can reliably deliver all these 5 elements safely. So the 5 essential of deliberate practice is focus, repeated practice toward defined goal, immediate specific corrective feedback, practice at the edge of the current ability, measurable performance against standard, coach facilitators to observe and correct. In a summary, deliberate practice is more powerful predictor for expert performance than experience or natural talent. So we'd like to move from here to here. Feedback should be integrated throughout the practice. We have a simulation and we have novice learner. They learn, then they have debriefing, then we provide them with feedback, then they go back again, they repeat simulation, they develop competency, then we give them a feedback again, then they repeat the simulation, and then they became proficient. After feedback again, they repeat the simulation, then they reach the master levels, and then we can increase the difficulty. So, and this is in alignment with the literature. So studies show that there is 82 reduction in the catheter-related bloodstream infection after using of simulations. Studies show that also skills learned in simulation lab transfer to patient care and improve population health by 3 times. And also studies show that mastery learning, every learner achieves the standard before moving on. And this is closely related to the deliberate practice. So again, we want to move from here to here. So we have briefing, simulations, and debriefing. Now we'll go through these 3 stages, but the significance of the briefest slide that we talk here, we don't want it to be abstracted in this way. No, we have to consider this deliberate practice in simulation. Going back to the Kolb cycle, as you can see here, so feedback should be integrated throughout the process with the aim that to enhance the deliberate practice, aiming at helping the learner to move from novice to competent to proficient and then to the mastery through the deliberate practice. Now we'll talk about the first part. The next of the slides, we'll talk about these 3 stages of simulation: briefing, simulation scenario, and debriefing.